Students, let's discuss a new topic today, that is group 14 elements, okay, which is also called as 4th A group elements, or we can call this as a carbon family. As a starting element of this group is carbon, we'll call this as a carbon family. Okay, so let's see the electronic configuration today. Their general electronic configuration is Ns2 Np2. So this group present after group 13 elements. Okay, now let us see the elements and their electronic configuration. So here I am writing element first. Next we are having symbol of that element with atomic number. Z indicates atomic number here, and finally we have electronic configuration. Okay, let us see this. So we are having first carbon. So carbon having atomic number 6. Okay, so if I fill the electrons in various orbitals, we'll get 1s2, 2s2, 2p2. 1s2, 2s2, 2p2. So you can get the valency 4. And otherwise this can be written as helium 2s2, 2p2. Here this 1s2 is a helium electronic configuration. So helium 2s2, 2p2. Okay. So coming to the next element, that is silicon. Silicon symbol Si and atomic number is 14. So if we write the electronic configuration, we'll get 1s2, 2s2, 2p6, 3s2, 3p2. So if we add all the powers, you'll get the 14 electrons. And you can observe this 1s2, 2s2, 2p6 is neon electronic configuration. Neon is a noble gas which is having 10 electrons. So it is neon electronic configuration. So I'm substituting this 3 with neon. Okay, neon 3s2, 3p2. Okay, next coming to third one, that is germanium. Germanium atomic number 32, symbol Ge. And we are having electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p2. Okay, so we can write this one in as argon 3d10, 4s2, 4p2. So argon is the argon is a noble gas with atomic number 18. So here we can observe up to 3p6 we are having 18 electrons. So I'm replacing this electronic configuration with argon. Argon with 3d10, 4s2, 4p6. Okay, so next coming to tin. Tin is representing with the symbol Sn, and we are having atomic number 50. So we are having 50 electrons in tin. So now we can fill the electrons in various orbitals, that is 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 4d10, 5s2, 5p2. So here we are getting a noble gas, that is Krypton 36, atomic number 36. So we can write 36 in place of all these orbitals. Up to here we can write, you can see 1s2, 2s2, here 10, here 28, 28 up to this, up to 4p6, we are getting 36 electrons. So it is replaced with Krypton 36 atomic number, Krypton 4d10, 5s2, 5p2. Okay, next coming to lead. Lead atomic number 82. So if we fill the electrons, we'll get this configuration. 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 4d10, 4f14. Next 5s2, 5p6, 5d10, 6s2, 6p2. So xenon is the element with 54 atomic number. So 54 will write up to here, we'll get the 54, and next we'll get 4f14, 5d10, 6s2, 6p2. Okay, so xenon is replaced instead of 54 electrons. Totally we are getting 82 electrons in lead. Okay, so this is just electronic configuration of group 14 or 4th A group elements. Okay, let us see the general properties. So coming to the next concept, that is general characteristics of group 14 elements. So here we will discuss some properties like atomic radius, ionization energy, density, boiling melting points, okay, and oxidation states. Okay, so let us see the atomic radius. So already we know what is atomic radius. The distance from the center of the nucleus to the valence shell is called atomic radius. Okay, so as we move from top to bottom, I told you already, number of shells increases as we move from top to bottom. Hence atomic radius increases. Okay, so here if you take carbon to lead, there is an increase in the atomic radius because number of shells increases and number of electrons increases, due to that number of shells increases. Okay, but when compared to group 13, so group 13 comes before this group 14 elements. So when we move from left to right, atomic radius decreases because number of electrons will be added in the same subshell, in especially in periods. Okay, so when compared to group 13, group 14 is having a small atomic radius. Okay, but from top to bottom, atomic radius increases because of number of shells increase. Next, coming to ionization energy. So I told you what is ionization energy. The amount of energy required to remove a valence electron. Okay, so as we move from top to bottom, the number of shells increases. So the nuclear attraction on the valence electrons decreases. So we no need to require more energy to remove the electrons. So as we move from top to bottom, IE values decreases because of increase in size, nuclear attraction, less nuclear attraction, or I can say decrease in the nuclear charge. Okay. So that is in this elements we can say smallest element is carbon. So carbon is having highest ionization energy. Okay. So next, coming to melting and boiling points. So melting and boiling point is directly proportional to the size. When we have a small size, then there is a more molecular attractions. Then we require more heat energy to break this force of attraction. But here, as we move from top to bottom, size increases. Hence, we can say less nuclear attraction. Large size, less nuclear attraction. Okay. Hence, there is a decrease in the melting and boiling point values. So when there is a less attraction, you need to supply more energy to break the forces. Here, by supplying some amount of energy, there is a conversion of a particular liquid into vapor takes place. So we can say melting and boiling point values decreases because of increase in size. Next, coming to the density. So what is meant by density? I told you already, density is directly proportional to mass and inversely proportional to volume. So as size increases, mass increases. Whenever the mass increases, we can say density values also increases from top to bottom. Okay. So let us see some more general characteristics. Is electronegativity. So electronegativity is nothing but tendency of an element to attract shared pair of electrons towards itself. For example, if I take A and B, two elements, B is more electronegative, then it attracts shared pair of electrons towards itself. That is called electronegativity. Okay. So here now electronegativity is more for the element which is having small size. So here from top to bottom size increases, so electronegativity values will be decreases. So carbon is element which is having more electronegativity in this group. Next, coming to metallic and non-metallic properties. So metallic property is nothing but tendency to lose electrons. So from top to bottom size increases, so they can lose electrons easily. So here we can say from top to bottom metallic character increases, non-metallic character decreases. So here we can say carbon and silicon are non-metals. Okay, germanium is called as semi-metal, and we can say it as tin and lead as good metals in this group. Next, coming to nature of compounds. So nature of compound means whether they are ionic or covalent compounds. Here mainly carbon and silicon forms covalent compounds. Because of their small size, they readily shares electrons. They can't lose electrons to form ions. Okay, because of the small size and more ionization energy, they shares electrons to form a covalent compound. But we are remaining elements, as size increases, they readily lose electrons and form a cation in order to form ionic compound. So here we can say germanium, tin and lead have a tendency to form ionic compounds because of their large size. They lose electrons easily to form cations. Okay. So next, coming to oxidation state. So next one is oxidation states. So these elements exhibits +4 oxidation state because their valency is 4. They can lose 4 electrons and they can exhibit +4 oxidation state. But some elements like germanium, lead and tin exhibits both +4 and +2 oxidation states. So they are exhibiting +2 oxidation state because of inert pair effect. So what do we mean by this inert pair effect? So reluctance of valence s electrons to participate in bonding. Reluctance indicates non-participation. So non-participation of valence s electrons to in bonding. Okay. So we can say that, for example, I am taking the general electronic configuration ns to np2. Here, these 4 electrons actually participate in the bonding. That's the reason they'll get +4 oxidation state. But some cases what will happen, because of inert pair effect, that means if you observe these 3 elements, they'll get D and F electrons in the valence, in their electronic configuration. You can observe D electrons and F electrons sometimes. So because of D and F electrons, the poor shield effect can be observed. So D and F electrons shows poor shielding effect, so that the nucleus attracts electrons, paired electrons towards itself. So because of the reason Ns2 electrons are paired, they attracts more towards the nucleus. Okay, so these are unpaired electrons. Np2 electrons are unpaired electrons. They readily participate in the bonding, but not Ns2 electrons. Okay, so this is called inert pair effect. So this is completely about general electronic configuration of group 14 elements. Thank you for watching.